Hi and welcome to the fifth instalment of the Cubics and Quartics revision. Now the first question here, solve the equation x to the 4 take 2x squared plus 1 equals 0. Now when I looked at this I thought to myself there's a little trick I might need to do with this one. And what I'm going to do with this little trick is I want to say let u equal x squared. And what I can then do there is everywhere I see an x squared I can replace it with u in this equation. So x to the power of 4 is equal to x squared, which if I let u equal x squared will just equal u squared. So what I can do is I can call this equation u squared, take away 2u plus 1 equals 0. And if I've remembered my expansions and factorising of quadratics, I will remember that this is actually u minus 1 all squared, which is equal to 0. So if you can't remember that, you might need to go back to your quadratics and just remember how to expand perfect squares. So a plus b squared or a minus b squared. Just remember the pattern that happens there. So now that I've simplified that, that looks much simpler than what the original expression was. I'm going to replace the u with the x squared that we had before. So this will now become x squared minus 1 all squared equal to 0. And if I look inside that, that now looks like a difference of 2 squares. So I'll just rewrite that as a difference of 2 squares. 1 squared equals 0. And I'm going to put it into square brackets instead of round brackets. And I'm going to factorise the difference of 2 squares. So this is sort of going to be like the big bracket on the outside, which is the square bit. And then the bit that's in the middle becomes x minus 1, x plus 1. That's equal to 0. Now what I can do is I'll square root both sides, gets rid of that square, which gives us x minus 1, x plus 1 is equal to square root of 0 is obviously 0. Then what we do is we take each of these brackets and we set them equal to 0, which will give us the solutions of x is equal to 1 or negative 1. And that's the answer to that question. Let's move on to the next one. Okay, for this particular question we're presented with a polynomial of x minus 2 to the power of 4 take away 16. Firstly, we're asked to find the x-axis intercepts. So for the x-axis intercepts we need to set y equal to 0. So for x-intercepts, y is equal to 0. That will then give us the situation where we have x minus 2, 4 take 16 equals 0. We'll keep rearranging this. We'll add 16 to both sides. Gives us x minus 2, 4 is equal to 16. Now if I take the fourth root of both sides, like so and like so, that will now mean that we have on the left hand side just simply x minus 2, and on the right hand side we have the answer of plus or minus 2. It's even this way, it's an even power, or it's an even root that we've taken, so we need to allow for both the positive and the negative root. Then the next step that we need to do is add 2 to both sides, so that will give us x is equal to 2 plus or minus 2, which will give us equals 0 or 4 as the 2 x-intercepts. Okay, so that's the first part of that answer. That's A. Now for B, if we go into a different colour, so if we go into B, if we're going to find the minimum value of this at this stage in the course, you haven't done any calculus or anything like that, so we need to use other methods to work out the minimum. Graphic calculator might be acceptable for your test or for your exam. If you don't happen to have one of those, then what you might need to do is to think about the type of graph that we might be producing, which is thinking ahead to part C here to sketch the graph. Now we have a Quartic graph. A basic Quartic graph would look something a little bit like this. And we have a couple of translations which have been applied to it. It's looking at the top here, we're going to the right by 2, and it's going to be going down by 16. So that's told us that our Quartic graph, we go across by 2 and we go down by 16, and that'll then mean that our graph will look something like that. So by working out that we now have a turning point at 2 and negative 16, we can then see that the minimum value is actually negative 16. Okay, the other way, you could, if you want to be sure about it, is it's been shifted across, the minimum's been shifted across to x is equal to 2. So we can substitute x equal to 2 into that equation, so p of 2 will be equal to 2 minus 2 to the power of 4 takes 16. 2 take away 2 is 0, so we don't need to worry about that, so that'll just be equal to negative 16, which we've already worked that out anyway. And by doing that, we've now got a bit of insight into what the graph is going to look like. So for part C, as we do things around to sketch the graph, we have x-intercepts at 0 and 4. Because we have an x-intercept at 0, we also have a y-intercept at 0. So I'll draw a little y and x. The graph will come down through there, down like so. We have an x-intercept at 0, we have an x-intercept at 4, and we have a turning point at 2 and negative 16. So that's the graph. Okay, let's move on to the next one. Find, in terms of p, the remainder when x cubed take 2x squared plus px take 6 is divided by x minus 2. So if we want to find the remainder, we use the remainder theorem. We're going to set x minus 2 equal to 0, which tells us that x is equal to 2. We're going to substitute that into the equation, and the answer that we get at the end is going to be our remainder. So our polynomial, substituting 2, will be equal to 2 cubed, take away 2 by 2 squared, plus p by 2, take away 6, which is equal to 8, take away 8, plus 2p, take away 6. These two will cancel each other down, which is just equal to 2p take away 6. So that's our remainder when that polynomial is divided by x minus 2, leaving the p in there. We don't know what p is at this stage here, and we have no solution. We don't know if that's a factor. So if we go into the second part of this question, find the value of p for which the same equation is exactly divisible by x minus 2. What that means is when we substitute x equals 2 into the equation, that the answer is going to be 0. We've already done a lot of that hard work. We know that the remainder for this is going to be 2p take 6, and that will be equal to 0 to have no remainder. So we'll just rearrange this, add 6 to both sides, 2p is equal to 6, which gives us p is equal to 3. And that's the value that we need of p, so that x minus 2 will be exactly divisible into the function. Okay, let's move on. The following graph has the rule f of x equals a, bracket x plus b cubed plus 2. Find a and b. So looking at this particular graph, if we had a graph of y is equal to x cubed, it would come up through here. We have our point of inflection at 0. The point of inflection for the graph that we have has gone across by 1 and gone up by 2 to get to that point there. So that gives us a clue straight away that our function is going to be a x minus 1, because it's gone across 1 cubed, and then up 2, which that's the positive 2 from the original thing. What we then need to do is we get this 0.36 and substitute that in to the equation to find a. So y equals when x is equal to 3, nope, that's not cubed, plus 2. So 6 will be equal to a times by 3, take 1 as 2 cubed, plus 2, or take away 2 from both sides, 4 is equal to 8a, 2 cubed is 8. Divide both sides by 8, which gives us a is equal to 4 over 8, or a is equal to a half. Okay, so we've been asked to find a and b. So a was equal to a half, and from what we worked out before with the translations, b is equal to -1. And they would be the answers to this question. Let's move on to the next one. A cubic function has the rule f of x equals ax cubed plus bx plus 4, and it passes through the points 1, 5 and 2, 8. Find the rule. What we need to do is to substitute both of these points into the function. We'll end up with two equations which we will solve simultaneously. So for the first equation, 5 is equal to a by 1 cubed plus b by 1 plus 4. Simplifying this, 5 is equal to a plus b plus 4. Take 4 from both sides, we end up with 1 is equal to a plus b. We'll call that equation 1. For the second equation, we'll do that down the right hand side here. We have 8 is equal to a by 2 cubed plus b by 2 plus 4. So 8 will be equal to 2 cubed is 8, 8a plus 2b plus 4. If we take away 4 from both sides, we end up with 4 is equal to 8a plus 2b. And that's equation 2, I'll call that one. Now what I'm going to do is I'm going to rearrange equation 1, and what I'm looking at equation 2 thinking it'd be easy to substitute b in for that one. So if I rearrange 1 by taking a from both sides, that will tell us that b is equal to 1 take away a. And I'll call that equation 1a. And then if we substitute that 1a into 2 across here, then what we end up with, and I'll change colour so you can see this is a little bit different with the substitution. 4 is equal to 8a plus 2, but b from over here is equal to 1 minus a. So keep going, 4 is equal to 8a plus, expand this out, 2 times 1 is 2, and 2 times negative a is negative 2a. Bring our like terms together, 4 is equal to 8a take away 2a is 6a plus 2. Take 2 from both sides, 2 is equal to 6a, which will tell us that a is equal to 2 over 6, or it's equal to 1 over 3. Okay. Now to work out b, we substitute that back into this equation here. So b will be equal to 1 take away a, which we worked out a as a third. 1 take away a third is equal to 2/3. So that now tells us that we can write the rule down. I'll just select a different colour here. Nice green. So the rule is going to be a function of x equals ax cubed, a is a third, so it's going to be a third x cubed, plus bx, b is equal to 2/3, 2/3 of x plus 4. And that down there is the answer to our question. And that's the end of this particular session. Hope that's been useful to you.